Alright guys, so here's a super quick overview of quadrilaterals. So we start with what is a quadrilateral? A quadrilateral is just any four-sided figure. So as long as it's connected, it's considered a quadrilateral. There's no specific shape as long as it has four sides. The next more specific quadrilateral we have is a parallelogram. So the parallelogram is pretty important because it kind of lays down the basis or the characteristics of all the other shapes. And so what's special about a parallelogram is, one, it has two pair of opposite sides that are congruent. So here we have your two sides are congruent, or your two opposite sides that are congruent. And apart from having two congruent sides, it also has two pair of parallel sides. So not only are they congruent, but they are also parallel. And what's special about their angles is that they have consecutive interior angles that are supplementary. What that means is, if you take your two angles, we'll call that angle A and angle B. If you were to add those two angles, supplementary means they add up to 180 degrees. And another thing is, the opposite angles of a parallelogram, they are also going to be congruent, which means the opposite angle is over here, so that angle is also going to be A, and this angle is also going to be B. And now something special about their diagonals. If you don't remember what a diagonal is, diagonal goes from one opposite vertex to the opposite one. So this is a diagonal, and here's your other diagonal. Now, what's important about those diagonals is the fact that they bisect each other. They're not all congruent, they just bisect each other. In other words, this yellow diagonal is going to bisect the blue diagonal. And so we denote that by using three little lines. And since the blue one is also going to bisect the yellow one, we're going to use 4. And the reason we're using a different number of marks is because they're not all congruent to each other. They're being bisected. And so that's the key parts or the key characteristics of a parallelogram. For a rectangle, we draw it in this way because, one, it has the same exact characteristics as the parallelogram, but it has two extra properties, you can say, that makes it a rectangle. With the first one being that it has 4 right angles, and the second one being that the diagonals, not only do they bisect each other, but the diagonals are also going to be congruent. And so, yes, they bisect each other, but since the diagonals are congruent, we know that all 4 of these parts of the rectangle are going to be congruent. And so from here we can still see that it has 2 pair of opposite sides that are congruent to each other, 2 pair of opposite sides that are parallel to each other. And we can easily see that if you take this angle and add it to that angle, they're still supplementary. So it also has consecutive interior angles. And we also see, since all 4 angles are 90 degrees, opposite angles are also congruent, which is all the properties for a parallelogram. On the other side, we have our rhombus. And once again, a rhombus has all the properties of a parallelogram. It also has 3 extra properties that make it a rhombus, starting with that instead of having 2 pair of opposite sides that are congruent, a rhombus is going to have all sides that are congruent. And there's something else special about the diagonals of a rhombus. Starting with 1, the diagonals are going to be perpendicular. Now, if you don't remember, perpendicular means they create a 90-degree angle. So we have 90 degrees there, 90 degrees there, 90 degrees here, all the way around where they intersect. Okay, and the other special thing about the diagonals that they do is they bisect the opposite angles. For example, if this, we'll focus on this diagonal right here. If that diagonal is bisecting the opposite angles, it means that this angle here is this big angle is being split up into two parts, two equal parts. So this little part is going to be congruent to this little part. And if we think back to the parallelogram, we knew that opposite angles of a parallelogram were congruent. Same case here. So if this angle here, we'll call it this green angle, is congruent to this angle over here, which is the opposite angle, and the diagonal bisects it, that means these two parts are also going to be congruent. And that's the same all the way around. So these two congruent to each other, also congruent to the opposite angles. And that's what's special about a rhombus. 1, diagonals bisect each other. Diagonals are perpendicular. Diagonals bisect the opposite angles, and it has 4 congruent sides. For a square, you can think about it this way. A square takes on both special properties of a rectangle and a rhombus. So essentially, a square can also be classified as a rectangle, also as a rhombus, and also as a parallelogram, because it has all of those properties put together into one. Starting with, it has 4 right angles, and that's the property we get from a rectangle. It has the diagonals that are congruent to each other. Once again, that's the property from rectangle. 2, it has the diagonals. Not only are they congruent to each other, yes, they bisect, but they also perpendicular, which means 90 degrees there, 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 and there. It has 4 congruent sides, which is the other property we get from a rhombus. And lastly, if the diagonals are going to bisect the opposite angles, well, let's think about it. If each corner was 90 degrees and I bisected, that means that now, when I bisected, each piece is 45 degrees here and 45 degrees there. And that's true all the way around. And so we can, if we zoom out, we can start seeing how all of these go together. And so here are all the shapes that we have, which brings us to the next one, which is called a trapezoid. Now, a trapezoid, we cannot classify it under parallelogram because a parallelogram has 2 pair of opposite sides that are both parallel and congruent. And so what's special about a trapezoid is that it only has 1 pair of opposite side that is only parallel. And those 2 sides is what we call the bases. So we can call it base 1 and base 2. Now, what we call base 1 and base 2, again, does not matter because it just represents a base. I could have called base 2 up there and base 1 down there. It does not matter. And so from a trapezoid, we have something that's called the median. And so what the median does to a trapezoid is, you can kind of think about it, it splits it halfway. It's the midpoint. So where you draw the median is going to be halfway between one of the sides. So in other words, the median is also going to bisect a side. Okay, and so we have what we call the median, and the way you calculate the median is you add your 2 bases, so base 1 plus base 2, and you take half of it, or in other words, you're finding the average. And that's pretty much it for a trapezoid. Now, there's also what we call an isosceles trapezoid, which has exactly the same properties of a regular trapezoid. The only difference is that for an isosceles trapezoid, it has one pair of opposite non-parallel sides that are congruent. In other words, these opposite sides are going to be congruent to each other. And the second special thing is that the diagonals are going to be congruent to each other. Now, it's not necessarily they bisect or anything like that. It's just the two diagonals are going to be congruent to each other. And so that's what's really the only other shape that we covered.